Alright, let's go for a new day of Advent of Code. Let's see, is my Bluetooth on? Yes. Okay, let's go. Setup for the airport, minimal steering. Okay, so it's a grid. Make a map. This is a map. Oh, jeez. Okay. Oh, so it's a puzzle. You need to reach the bottom. Toboggan can only follow specific slopes. Oh, okay. Difficulty ramps up. Let's see. Start by counting all the threes you would encounter for the slope. Right 3, down 1. I don't understand. Check the position is right 3, down 1, right 3, down 1, until you go past the bottom of the map. Yeah. 7 trees. Oh, okay, so we don't actually have to do the puzzle right now. Starting at top left corner of your map and following the slope of right 3 and down 1. Okay. Let's see, that's our puzzle input. That sounds weird. That sounds weird to me because it's way too thin. I don't know how many lines there are in here. Let's see. If I go right down, down 3 every time, I'm gonna reach a problem very fast. Let's see, file, input 3, yes, just a text file. I said yes. Yeah, sounds to me like we have too many lines. Let's see, println. Okay, so as usual, I'm going to start by reading lines equals read lines as using lines, and then I want input 3. And then I want to see how many lines there are. Size up. Oops. Run it. Okay, so we have 333 lines. So my problem is right now, if I go do exactly what they're asking me, I'm going to be done here, and I don't have to read bottom, so I don't understand. I need to understand how to recreate the map again. There aren't only, these aren't the only 3 trees. Oh, the pattern repeats. Yeah, so what I understand is essentially, if I reach the bottom, the end of that line, then I have to do this pretty much. Okay. Okay, so it sounds like what we can do is essentially we're gonna go through the lines. We're gonna keep a pointer x, which is the amount of so we're gonna start at 3, so this is gonna be it's going to start at 3, then it's going to start at 6, then it's going to be 9, then it's going to be 12. So write 3 every time, and then we're going to go down to the next line. Every time if we encounter a 3, we're going to get an accumulator, essentially. It starts at 0, and then if we have how many, what do we want? How many trees? Okay, so we're going to do a plus equal 1 if we have a tree. And I just need to have lines repeat indefinitely. But I think, so let me try. But let's say I have a line which is, I'm gonna try something dumb, and we're gonna see if we can use the, okay, so if I print out the size of the line, the length of this line, this is 31. Line is 31 length. So, but if I do println, and if I want the line, oops, and I want the index, let's say at 89, I want to see if Kotlin's going to help me. No, Kotlin's not going to help me. Kind of logical. I mean, I could transform the line every time and then just copy it several times. It sounds shitty, but why not? You know. What I can do is just a modulo, right? Val mod equals 89's. Let's see, how's modulo in Kotlin? It's gonna be the percentage, right, as usual. Remainder. Reminder. Let's see, how does it work? Okay, so if I do 89 line dot length, how does it look like? That's not how it works, does it? Oh, okay, let's try. Up equals 89 dot rem. No, rem's not known. Rem. How do I use rem? How the... Okay. I'm confused. I can't use rem on an int. How does it work? Naja, just like I was expecting it. Let's see, 89, 31. Rem equals 89 divided by 31 plus, no, I don't want to do plus, and I'm too lazy to do string templates. Oh, okay. Yeah, so what that means is, of course, if I want to do the 89th index, what I'm going to get is 31 plus 31 plus 2. '27, sorry. So essentially, what I want is print line of 27. I'm going to check my off by 1 now. Okay, so I'm going to do that, and I'm going to say plus line plus line. So I'm going to make a string concatenation, and I'm going to check the index of 89 here, and I want the same. Okay, that's not good enough for me. A, B, C, D. That's 26, 27, 28, 29, 30, 31. Okay, we're good. No problems here. Okay, so we can try our thing. Let's see. So what we're going to do is, we're going to do lines. Let's try to make it in a single flat map, which we probably should be able to. Here, a flat map. No, it's not a flat map. I always get it wrong. Jesus. It's a reuse. We're going to start at 0, which is the number of trees we have, the trees we have. And then we want a function that takes the accumulator and a line. And I'm not going to start at 0, I'm going to start at a pair, which is going to be the result, but also, let's see, what I want to check is, where do we start? Okay, we will start at nothing. Okay, we'll start at nothing. I don't want the first line to count. I don't want the first line to count. Okay. I can just remove the line. If I do lines dot sublist, that's bad. I don't like it. Okay, println less lines dot o size. Let's see what happens there. Okay, we have one line less, and now we can take less lines. start at 0. And now our accumulator, what we're going to do is, we're going to do pair, and we're going to say something we don't know yet. But this is going to be acc.second plus 3. Is that going to work? And we're going to say i.first. Can I do that? No, do I have to do it in one line? Let's see. Oh yeah. If I do this, this should work. No, not even. I need. Is that fold? Did I? Ah, it's not reduce, it's fold. Not very smart. Right, I can't do that in several lines. That's caca. Okay, so the only thing I miss now is this should be +1 if we have a tree in that line. So if we're going to do lines, oh, I've removed the stuff we were doing a second ago. So lines, no, line of, we said the is going to be the, was that the modulo or not? No, it's going to be this. So we're going to divide act.second by line.size, length. If this is a tree, then act.first +1. I'm writing too many different languages. I'm losing myself at some point. Else act.first. Okay, and now we have a char and a string. Yes, so we're going to do dot to string to char. The other way around, to string. Okay, so if that is 95, what happens if we, I'm wondering, just going to check one last thing. What happens if my line is CDEF and I want the, we're going to do the same thing, so I want the third character Is that gonna work? D. Why D? I would expect C. 3. One, two, three, 4, 5, 6. And if I do 6 plus 3, that's going to be 9. D again. Okay, let's do input 3 test. And try on the test input. I'm so extremely bad with anything off by 1 related. It is horrendous. So, tack, tack. And here, what we're getting is var results. And what we want to print is essentially results dot first. And I'm not doing it in a very clean way, but it works. That should work. Let's see. Input 3 test. Okay. Two. No, we have an off by 1 problem. Because I would expect okay, we're gonna make a function out of it. Private fun process line, and that's gonna take a string as input, and it's gonna take a pair. Let's see. I'm gonna even call it ag. A pair of int and int, and it's gonna return a pair of int and int. Okay, and I'm saying a return. There you go. And I'm going to do here for ag and line process line like this. Okay, we should still have 2. But now what I want to do is I have more space to do stuff, so I'm going to start by printing the line. I'm going to also print a separator. If I'm having problems like this on day 3, I can't imagine day 15. Okay, and now I'm gonna print, let's see, the is3. Number of trees. Up. What I want in there is found spot. And I want to print it every time. Because I want to know what we're finding. Yeah, let's try that. Okay, so here we're starting with this. Oh, this is 0 problem. You have to start at 3, I think. Yes, that's the problem. Yeah, of course, because I was starting, so I removed the first line to avoid having to count it. But then I started this line on 0. Okay, so now let us try to remove those prints. And then try on the real inputs. 189. Yay! Okay, that worked. First try! Still, I like it. Okay, next. So we're gonna clean that up a little bit. Up. Okay. Now, second time. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop. Okay. Oh, that sounds easy. Multiply together the number of trees on each of those listed slopes. We have to go down to, okay, our only problem is going to be to be able to go down to, and that screws pretty much everything in my process line. Because I have to be able to integrate the fact that we have to process some lines and some others not. And that would be fixed much easier with a for loop. I could filter. Okay. Let's try something stupid. So what I'm suggesting is, for all of these cases, we can do the same thing. We can just use the same again. Now for this one, we can't, but if we remove half of the lines, then we can. All of a sudden, because it's going to be down 1. How do we remove half the lines in an efficient way? I'm going to do 1, 2, 3, 4. So I'm going to do result 1. So that's going to be result 2, 3, 4. This is 1, 1, 3, 1, 5, 1. So 1, 1, 1, 3, 1, 5, 1, 7, 1. And here we basically have to do this, 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 this. But now we have to do a 1, 2. And that's our problem. This comes back to 1, down 2. So we have to down 2. So less lines is going to change. Even less lines should be so in the case of our test, here, what we would want is essentially this plus this plus this plus this, and then remove the first. Okay, let's see. Clean list, keep out of 2. No. What's the easiest way to do that? I could do that in a very hutje-tutje, zullen we zeggen in het Nederlands. I could just make a for loop, I could flatten, I could fold it again. But I want to see if there is something in the library that allows me to do something. Nice. Yeah, not really, I think. I can remove the first n, I can remove the last n. Okay, let's see. I can do lines dot. Is there a filter indexed? Yeah. Okay, so if I have a filter indexed, then I have the index and the line, and I want the index modulo 2 to be 0. Let's try that and see how it looks like. So I want to try with the test again. And here I'm going to keep that guy for the end. Even less lines. Val the least lines equals even less lines. And I'm going to use the same little dirty trick. Up. Up. And now what I want is results 1 times first times results 1 2 times results 3 1 first times results 5 1 dot first times results 7 1 dot first. Let's try. Oh, doesn't want it. Oh, I forgot first here. Oh boy. Okay, not happy. Where is it complaining? 39. Oh, of course. If you copy paste stuff, then it's not gonna work. Okay, so we're gonna have to print because we are clearly wrong. Okay, 1 1. I want to see which one's wrong. So 1 1 is okay. Then we have 3 1. Then we're gonna keep 5 1. Then we're gonna keep 7 1. And we'll keep 1 2. And I want to see which one is incorrect. Down, 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 up. Okay. So 3 7 3 4. Oh, we do have a bug. Every single time. I'm actually even wondering how. Okay, the first one. Let's see. What did I do? Okay, so what's happening is we take less lines. And we start at 0 trees, and then we start at 1, we take the first one. Let's see. We take the first one, we find it, we accumulate. Oh, here. There's a bug here, of course. Do I have any reference to this one here? No, I don't. Okay. Step int. One. I don't like it. It's a bit crappy. We can make it cleaner later. 5, 7, and here would be 1 again. Okay. That's what happened when you hardcode 3. 372 3. What? 1 should give me 2. I forgot to take it into account. You're going too fast. Okay, 27342. 27342. Yes. And then let us try on the real results. Oh boy, that's big. Yay! Okay, so day 3 is the first time we actually do not find those results every time. Okay, I'll do day 4 later. Cheers, guys.